Good morning, friends. Today we'll start with the next problem on D elements principle. Already I sent earlier the 2-3 problems, and I think you might have gone through it and you might have understood. None of you have not responded back to me. Any improvements are required, just you call me and tell me regarding that. Or any doubts are there also, you can call me and clarify the doubts. Now, this is the problem where a 1200 Newton load is kept on the sloping floor, and 800 Newton is connected to it by a string on a frictionless pulley. As the 800 Newton load is suspended and connected to the 1200 Newton, it pulls it down in the downward directions. So both the blocks, 1200 Newton block moves upwards, and 800 Newton blocks as suspended it moves down. Because of that, and both will have the same acceleration a, and both moves in this moves in the downward directions. Now, as they are under dynamic equilibrium, we are required to work out three things as you have seen from the problem. One is the tension in the string, acceleration with which the body moves, and the what is the distance it moved after 3 seconds. These are the three things have been asked, which can be solved by D'Alemans principle. Whenever you come across with the determination of acceleration, you have to work out this one. Now, as there are the two bodies, we'll have a free body diagram for each body separately. Now, you just first concentrate on the first body, that is a 1200 Newton block. As it is on sloping roof, and the slope is 12 degree. So, this free body diagram is shown here. That is N is the reaction, and 12 Newton for load is weight is acting in the vertical downward directions. T is the tension in the cable, and 1200 by 9.81 into A, that is nothing but MA of the body, and this is always opposite to the direction of the motion of the body. As the block moves upwards, the direction of this motion will be in the downward direction. And frictional force between the floor and the body is F, and that also acts in the opposite direction in the downward directions. Now, the tension is the only thing which moves in the right direction, and component of the 1200 Newton force is also in the downward directions because it is uphill floor is there. Now, under the equilibrium, first of all, you equate all sum of the forces perpendicular to the plane should be equated to 0. So therefore, the 1200 Newton is vertically downwards. The perpendicular to the plane is 1200 cos 12 degree. That is, N is acting upwards, and 1200 cos 12 degree is acting downwards. So therefore, N minus 1200 cos 12 is equal to 0. It is the equilibrium condition for this one. Now, from that you will get N is equal to 1173.77 Newton. Next, you will go for the same equilibrium condition, but before that, you will work out the frictional forces. As you got the N, as you know that F is equal to mu N, mu is the coefficient of friction that is given is 0.2. Therefore, F is equal to mu N, and that is equal to 0.2 into 1173.77. So it works out to 234.76 Newton. Now, we will apply equilibrium condition for the forces parallel to the plane. So therefore, in that case, as I told you, three forces will be in the downward directions, and only the tension is in the upward direction. So therefore, by equating, they should be under equilibrium, under dynamic equilibrium. So the equation works out 1200 upon 9.81 A, that is MA inertia force, plus 1200 sine 12, component of the weight in the downward direction, and plus F, frictional force, just now we worked out, that is also acting in the downward direction. And tension is in the right direction, that's why minus T is equal to 0. So this will give a equation of 122.32 A minus T is equal to minus 484.25. This is the one equation you get it from the 1200 Newton block. And similarly, for the free body diagram of second body is also required to be considered. Free body diagram is shown you, that is tension in the upward direction in the cable, weight of the block 800 Newton is acting downwards. As the block is moving downwards, there is no other contact with the bodies and hence the inertial force will be acting 800 upon 9.81 into A, that is acting in the upward directions. So under this equilibrium condition, apply all sum of vertical forces should be 0. So by applying that conditions, that is T plus 800 upon 9.81 A is equal to 800. That is the entire weight acting downwards. So these two earlier one equation and this second equation, both equations, if you solve for, there are two unknowns, you solve for the A, you will get A is equal to 1.549 1.549 meters per second square. That is the acceleration of the both the blocks. Now substitute that acceleration in any one of the equations, you will get 673.68 Newton is the tension in the strings. Now the third point they have asked you to determine how much what is the velocity at the end of this one after 3 seconds. What is the velocity of the blocks after 3 seconds? Now we have already earlier in the session, just to brush it up whatever I sent, I have discussed regarding the linear motion equations. By using that linear motion equation, S is equal to ut plus half at square, substitute initial velocity is 0, acceleration of the blocks is 1.549 meters per second square, and t is 3 seconds. Substitute that one, you will get the velocity as 6.97, distance not velocity, you have to work out the distance, and that is equal to 6.97 meter. That will give the how much distance it traveled in 3 seconds is given. Okay. I will send one more problem. This is the one video for the this first, third or fourth problem. Okay. Thank you.